Welcome back, guys. All right, so we're going to be moving on. Our next topic in our trig unit is called transformations of sinusoidal functions. So in the last unit, in the last lesson, we talked about what the graph of y equals sine x looks like and what the graph of y equals cosine x looks like, and how the a and b values affect the amplitude and the period. So we're going to kind of be continuing along the same theme for this one over here, but we're going to be dealing with like the horizontal translations and the vertical translations for these guys in addition to the a and b values as well. So there's more transformations of these guys. So what each of these guys does so far is that the amplitude of our graph equals the absolute value of a. If a is less than 0, there is a reflection in the x-axis. What this b value does is we know that the b value has to do with the horizontal stretch of the factor of the function, which is going to give you a horizontal stretch by a factor of 1 over b. So the period equals 2 pi over b, and that's the length of one cycle, or if we're in degrees, it's going to be 360 degrees over b. So depending on what the units are in radians or degrees, this is the formula we use to figure out our period. Now this c value is going to be the horizontal translation, but we have a very sweet new name for this in this unit, and we call the c value the horizontal phase shift. Really, it means the exact same thing as horizontal translation, but we just have different terminology when we're talking about sinusoidal functions. Same thing for the d value here. Normally we call this one a vertical translation. I have another very cool name for this one over here, but this is going to be called a vertical displacement. And those are what these parameters are going to do to our graph. Bit of review. Y equals sine x. Okay, now we covered this in the last topic, but here's how I'm going to show you how we do this one. So this is a regular y equals sine x. That means the amplitude is 1 and the period is going to be 2 pi. So for sine graph, it starts here and it's going to end at 2 pi here. Okay, so we're going to draw those 2 points first. Next point we do is we're going to cut this in half and it's going to cross there. Next, we're going to split these two guys up and put a point here. Split these two guys in half, put a point down here, and then extend this pattern throughout the graph like this. And this graph is going to look like this graph is going to look like this guy over here. This is how we graph y equals sine x. Okay, so the points would say I draw this point first, then this point second, this point third, this one fourth, and this one fifth, and then just kind of extend the pattern after this. Same idea for y equals cos x, except for cosine graph, we need to know that the graph starts over here. So the graph starts at the maximum point at 0, 1, and it's going to end at 2 pi at 1 over here. Next, if I split these guys in difference, I'm going to draw the minimum point here, and then I'm going to do these two x-intercepts like this. So in order, I would have gone 1, 2, 3, 4, 5. Okay, and then I'm just going to kind of follow this pattern going forward. So I have a point here, point here, point here, and points like this, and this graph would look like oops. Okay, and that's how this graph's going to look like. So there's kind of a lousy drawing over there, but this is how we kind of sketch these graphs. All right, so right into it. We need to sketch the graph of y equals 3 cos 4 x minus pi over 4 plus 2. Okay, so I mean a lot going on in this transformation over here, but we're going to start with this d value here. Okay, and this d value we can describe this is that this is going to shift the midline of this graph up 2. So I'm going to draw a dashed line over here, which is referring to the midline of our graph. Okay. Now the amplitude, we know that amplitude is 3. So if I look at the midline and I count 3 units up, so like 1, 2, 3, I'm going to draw the max line here. 1, 2, 3 down. I'm going to draw the min line. So we have the max line, the mid line, and the min line here. Okay, so we're going to do this and again. So the midline is based off the d value. The midline gets shifted up 2. The amplitude is 3. So the distance from the midline to the max and the midline to the min, we're just counting up 3 units and down 3 units as well. Okay. Next, what we're going to do is we're going to look at this. Our horizontal phase shift is pi/4. Okay. Now, if we look backwards over here to the previous example, we have to realize that for a regular y equals cosine graph, the graph is starting over here at 0, 1. It's starting at the very top of the graph on the max line on the y-axis. So normally this graph would be starting here, but we've been moved pi/4 to the right. Okay? So that means the starting point, my first point is going to be, here. Okay. Next, let's look at this. Our period equals 2 pi over 4, which is pi over 2. Okay, so pi over 2 is going to be the period. So if you remember back to the previous example, we started here and we ended over here. This was period. This was number 2. Now, from here to here was 2 pi, which is normally the period of cosine x. So like my second point would start here, and I'd count the period going this way, and that would be point number 2. Well, pi over 2 would be, so like pi over 2 is from here to here, but I'm going from here to here now, because like this distance from here to here would be pi over 2. Okay, so here's my point 1, here's my point 2. My point 3 is halfway in between at the very bottom. This is point 3. Okay, now my point 4 goes halfway in between on the midline. Here's point 4. Halfway in between on the midline, point 5. Oops, point 5 like this. So there are my 5 points. And now I'm just going to extend this pattern and fill out the rest of the graph. So I have a point here. And I'm just extending this graph, following this pattern like this. Like this. Come in.